So, number 36 said, prove, this is part B, prove AB is symmetric. Guys, I'm going to write this, IFF. Did I give you guys that abbreviation yet? If and only if. And again, it's AB equals BA. This is what we're trying to prove, right? So I'll tell you what. I'll do one direction. And then if you guys want to try the other direction, that's fine. So if I'm going to do this direction, I'm going to start off with AB is symmetric. So we are given that AB is symmetric. And of course, down at the bottom, I'm going to write AB equals BA. I hope I get that. So now it's time for like the unpacking part of. So if you had trouble with this, write it down, and then I'll have you guys do the other direction. This is already an equation at the bottom, but the top is not. But what's the definition of symmetric?
AB equals its transpose.
Yeah. So I'm going to write down AB equals AB transpose. And that's actually cool because I already have the left-hand side of the equation done. So now I guess the next question is, can I go any farther? Can I work on the right-hand side? Can I simplify somehow, right? Yeah, I guess is that true? Is it true that AB transpose? Well, let me try it on a MATLAB. What the heck? So do we have a matrix B in here? No, that's not big enough. Let's make B is a matrix full of ones. Yeah, that's a different one. There's a different matrix B. Okay, and here's my matrix A. So what do I want to try here? Oh, I want to try A times B, that guy. Oh, but what I really want is I want A times B transpose, that guy, right? And so the question is that equivalent to, what are we saying that equals? A transpose times B transpose. Negative. Not the same. But wasn't there something in the book about that? Hold on a second. Where was that?
Yeah, it's a property. Oh, it's backwards.
Yeah, B transpose
It's B
times A
transpose
transpose.
times A transpose.
It equals B transpose A transpose. That's what you guys are telling me?
Yes.
Okay. So let's take a look at this. Where am I? Here. Let's do, again, here's AB transpose, and let's do B transpose times A transpose. Now that's not proof, but it's evidence, and I think you believe that it's true. I like to call this property, I think this book might have been where I learned this. You call it the shoes and socks rule. The shoes and socks rule. You might say, why? Well, because in the morning, you put on your socks and you put on your shoes, right? But then you want to undo it. What do you have to do? Take off your shoes, then take off your socks, right? Actually, where I usually see this is this one, AB inverse. What does AB inverse equal? Did you guys read that? It turns out that AB inverse is not A inverse B inverse, but it's B inverse A inverse. Maybe I'll prove that next. But by the way, we're almost done. How do you get from this red one to that blue step? Well, we were given something else that we didn't write. We were also given that A and B are what? Yeah. So given at the top, A and B are symmetric. And that means, otherwise this isn't true. But if you have A and B symmetric, then you can go from here to here, because B transpose is the same as B and A transpose is the same as A. Yeah, I want to talk about the shoes and socks rule for the inverses. I want to talk about that next. So, how do you show that this is true? Well, when I say AB inverse, what does that mean? It means, hey guys, here's AB, multiply it by AB inverse, and what's it supposed to equal? It's supposed to equal the identity, right? But to see why the shoes and socks rule is true, think about it without parentheses. If you have A and then B, and you're trying to get the identity, you want to write it this way. Because then what happens? You get AI A inverse, because this part in here is the identity. And remember, you can't switch the order, but you could switch the grouping. And so you get BB inverse is I, and now A times I is just A, and now what's A times A inverse? That's identity. Does that make sense to people? As a matter of fact, if I asked you guys, what does ABC inverse equal, what would you say? C inverse, B inverse,
A inverse.
A inverse, right? I mean, the same reasoning. It's the only way you can get the identity is if you turn around the individual inverses in the order of multiplication.